Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to discuss colloids. Last class I have discussed characteristics of enzymes catalysis. Now I am going to discuss colloids. This is very important topic. We know that solutions are homogeneous system. We also know that sand in water when stirred gives a suspension which slowly settles down with time. Between the two extremes of suspensions and solution, we come across a large group of systems called colloidal solution. Called colloidal dispersion or simply colloids. Between the two extreme suspension, between the two extreme of suspension and solution, these are important things. Between the two extremes of suspension and solution, we come across a large group of systems called colloidal dispersions or simply colloids. A colloidal is a heterogeneous system. A colloidal is a heterogeneous system in which one substance is dispersed as very fine particles in another substance. A colloidal is a heterogeneous system in which one substance is dispersed, that is called dispersion phase, as very fine particles in another substance called dispersion medium. Means substance is called dispersion phase, dispersed phase, substance which you are dissolving, and another substance is called dispersion medium, just like a solvent in which you are adding the substance, that is called dispersion medium, just like a solvent. The essential difference between a solution and a colloidal is that of particle size. Difference between solution and colloidal. What is the main difference? Then the essential difference between a solution and a colloidal or colloid is that of particle size. While in solution, the constituent particles are ions or small molecules. In a colloidal solution, what will be there? In a solution, while in a solution, the constituent particles are ions or small molecules. But in a colloid, the dispersed phase may consist of particles of a single macromolecules, macromolecules such as protein, synthetic polymer, or an aggregate of many atoms, ions, or molecules. Okay, here again I am telling you that in a colloids, the dispersed phase may consist of particles of a single macromolecule, macromolecules such as protein, synthetic polymer, or an aggregate of many atoms, ions or molecules aggregate, not only single ions, aggregate of many atoms, ions or molecules. Actually here size is bigger than ions. Here size is bigger than ions because it is a collection. It is a collection, aggregate of many atoms, ions or molecules. But in solution, particles are ions or small molecules. Okay. Then in solution, particles are small, just like ions or molecules, small molecules. But in colloid, dispersed phase is bigger size, macro, MAC or macromolecules. The example of macromolecules are protein or synthetic polymers, or you can tell aggregate means collection, aggregate of many atoms or many ions or many molecules. Okay, or molecules you can tell, many molecule will just get together, then collectively it is called these things dispersed phase. Okay, dispersed phase, all are the dispersed phase, correct? Aggregate of atoms, aggregate of ions or molecules, all are called dispersed phase. That is the colloid. Colloidal particles are larger than simple molecules, but small enough to remain suspended. It should be not very big. It should be in a position to suspend in the solution. Okay, it should not be very big. Colloidal particles are larger than simple molecules, but small enough to remain suspended. Their range of diameter is between 1 and 1000 nanometer. This you remember, question is asked. The range of diameter of colloidal particles I am talking about between 1 and 1000 nanometer means 10 to the power minus 9 to 10 to the power minus 6 meter. You know that 10 to the power minus 9 meter is equal to 1 nanometer. 10 to the power minus 9 is equal to 1 nanometer, and size will be between 10 to the power 9 to 10 to the power minus 6 meter. This question is asked. Now, colloidal particles have an enormous surface area per unit mass. Okay, this colloidal particles have an enormous surface size per unit mass as a result of their small size. And now I am telling you these things. Classification of colloids. Colloids are classified on the basis of the two major categories are there. Colloids are classified on the basis of two categories. First is that physical state, on the basis of physical state, and second on the basis of, you can say, types of particles. Okay, the other two, this is classified on the basis of first physical state, and second this types of particles of the dispersed phase, and third is nature of interaction between dispersed phase and the dispersion medium. It is divided into three. First, that is on the basis of physical state. Second, nature of interaction nature of interaction between dispersed phase and dispersion medium. And third, type of particles of the dispersed phase. Okay. Depending upon the whether dispersed phase and the dispersion medium are solid, liquids or gases, 8 type of colloidal systems are possible. 8. A gas mixed with another gas forms a homogeneous mixture and hence is not a colloidal system. This you remember. A gas mixed with another gas forms a homogeneous mixture and hence is not a colloidal system. Okay. Then I told you that this depending upon whether the dispersed phase and the dispersion medium are solids, liquids or gases, 8 types of colloidal systems are possible. Okay. The examples of various type of colloids now I am telling you. Then here you can say I am telling you all 8 types I am telling you. First, solid plus solid means dispersed phase is solid and dispersion medium is also solid. Means solid plus solid. Actually this is called solid sol, SOL, sol. For the colloidal solution, the term sol is used, SOL. Okay, only solution means we are talking about homogeneous. Homogeneous solution is called solution, homogeneous, completely mixed. But if suspension is there, it is like a solution, but it is suspended. That's why another term SOL, sol, is used. Then solid plus solid means dispersed phase is solid, dispersion medium is solid. Dispersion medium is just like you can consider like a solvent, maybe ethanol, methanol, water, correct? That is called dispersion medium in which you are dissolving. Then solid plus solid is the first system, that is called solid sol. Then what is its example? Solid plus solid, this is called solid sol. Then its example is some colored glasses and gem, okay, gemstone, gemstone, because it is solid. You've seen solid plus solid, obviously it will be solid. Then colored glasses and gemstone. This is the actually example of solid plus solid, solid sol. Second example, second type I am telling you, second system, that is solid plus liquid. See, here usually you can understand this 3 times solid, 3 times liquid. Then it become 8 and 2 times gas you have to use. Continuously 3 times solid, 3 times liquids, 2 times gas. Because gas plus gas, that is not coming under the colloidal solution. Okay, then only 2, gas 2 times. Then and with each solid you can start just solid plus solid. Then solid is common for 3 and liquid and gas will be mixed in solid. Then solid plus liquid, solid plus gas. Then three types, another 3 types. Now continuous 3 times liquid will be common. And then again solid, liquid and gas will be mixed. Then it will be liquid. Suppose you started the liquid plus solid, liquid plus liquid plus gas, and solid, liquid, gas, one by one you can mix. Then this is the 3 types: solid plus liquid plus a solid, liquid plus liquid, liquid plus gas. 3 times liquid is common. Just like above, 3 times solid is common, and this solid liquid gas mixed. Like that way, 3 times liquid is there. In that solid liquid gas one by one will be mixed. And gas again only 2 type, means solid and liquid. Okay, because then gas and gas is homogeneous. Then now I am telling one by one that solid plus solid, it is called solid sol. Examples I told you, colored glasses and gemstone. Now solid plus liquid, that is called only sol. SOL, only sol it is called. Solid plus liquid, it is common actually, solid plus liquid. Then here it is called sol, not solution. SOL, sol, because size is bigger than solution particles. Solute is there in solvent, that is the solution. That solute is very, very small in comparison to suspended particle of colloidal solution. In colloidal solution, solute is bigger, that is 1 to 1000 nanometer. Between that, size is big. Then solid plus liquid, that is called sol, and its example is paints and cell fluids. In botany zoology, you are knowing the word cell. In that cell, fluids will be there. Fluids means maybe liquid, maybe vapor or gas. Then combined weight is called fluid. Liquid plus gas or vapor is combined weight is called fluid. Then its example is paints and cell fluids, you can tell. Now solid and gas. Its example is a smoke, dust. And solid plus gas means solid you have dissolved in gas. Then it is called aerosol. Question is asked. All 8 questions these questions are asked in examination, all competitive examination, including general like UPSC or any other examination. Then solid is dissolved in gas. Gas is more, solid is less. That time it is called aerosol. Example is a smoke, dust. Okay, smoke and dust is the example of aerosol. Now come to the 3 solid. I told you solid plus solid, solid plus liquid, solid plus gas. Now I am coming toward the liquid. Liquid plus solid. Now liquid you are dissolving in solid. Solid is more, liquid is less. Keep in mind. What you are writing first, that is less. Dispersion medium, dispersed phase. First I am telling dispersed phase, and second I am telling dispersion medium. Dispersion medium in more quantity, just like a solvent. Then now liquid plus a solid. Liquid is in less quantity, solid is in more quantity. Then it is called gel, GEL, gel. Okay, and its example is cheese, butter, jellies. Don't forget, for the medical these questions are fit. Okay, liquid plus solid. Liquid is dispersion phase and solid is dispersion medium, means solid is more and liquid is less. Then it is called gel, GEL, gel. Just like you have seen paste, toothpaste, that is also an example. Then that is called gel. Other example is cheese, butter, jellies. Now liquid plus liquid, both are liquid, but one quantity will be less, other liquid will be more. Then that is called emulsion. Very important questions for all examination. All eight categories what I am telling you now are important for all exams. Okay. Then liquid plus liquid, two liquids you are adding. Then first liquid is in less quantity, other liquid is in more quantity. Medium always will be more quantity. Then liquid plus liquid, that is called emulsion. Example is milk. Hair cream, you are putting cream now on hair, that is that hair cream. Then hair, milk and hair cream, HAIR, hair cream, which you are using for creams used for hair, that is called hair cream. Then this is the example of emulsion. And liquid plus gas means less liquid, more gas, that is called aerosol. Aerosol, that also I told solid plus gas, that is also aerosol. Solid plus gas, more gas, less solid. Okay, solid plus gas, that is aerosol. Here also it is a mixture of gas and solid, but in a reverse way. Okay, gas plus solid. Solid plus gas or gas plus solid is called aerosol. But if gas is less and solid is more, then it is called solid gel. Solid gel. Okay. When gas is this things aerosol or sol, I told you about the liquid plus gas. चलिए 2 times I told you use the word aerosol. First solid plus gas, that is called aerosol. Now I am telling you liquid plus gas. Means liquid is in less quantity, gas is in more quantity. Okay, then whether solid or liquid, anybody, if it is mixed in a gas, then it is called aerosol. Okay, gas is in more and solid or liquid is in less quantity. Okay, but gas is common. Gas is common. In gas, if solid is mixed or liquid is mixed, okay, it is called aerosol. Then now I am talking about liquid plus gas is also called aerosol. Its example is in winter you might have seen fog. Fog. Here in a gas, liquid will be there. A small amount of liquid will be mixed with gas. That is called fog. Second example is mist. M-I-S-T. Mist. Third example is cloud. Fourth example is insecticide. Insecticide, you can say a spray. A spray, wherever a spray will come, means gas is there. In that gas, some liquids are there. Sometimes, generally, liquids will be there. Okay. Then fog, mist, cloud, insecticide, sprays. These are the examples of aerosol. Now, come to the gas. Then, gas 2 times you have to write, because gas plus solid, gas plus liquid. No, gas plus gas, no. Because it is homogeneous. Homogeneous means come under the can say solution. Then gas plus solid. Gas is less, solid is more. Gas is less, solid is more. Gas is dispersed phase, solid is dispersion medium. Then it is called solid sol. Because solid is more. Wherever solid is more, in first case solid plus solid, that is also solid sol. Here also solid is more. That's why it is called solid sol. Then gas plus solid, that is called solid sol. Okay, gas plus solid, just you don't forget. Then its example is pumic stone. Okay, pumice stone, P-U-M-I-C-E, pumice stone. Foam, rubber, you can tell, foam, F-O-A-M, foam, rubber, pumice stone. These are the example of solid sol. Okay, but here gas is in solid. Solid sol example, actually difference is that solid plus solid, that is also solid salt. Okay, and here gas plus solid, where solid is in more quantity, correct? Then wherever solid is there, except in gel, liquid plus solid, that is called gel, GEL, gel. But other two is called solid. Means solid plus solid, gas plus solid. Only liquid plus solid is called gel. Then gas plus solid is called solid sol. Example is pumice stone and foam rubber. And last is gas plus liquid. Gas, only two are there, gas plus solid, gas plus liquid. Then here liquid is more, gas is less, correct? Then it is called foam. Foam is the example of this system. Gas plus liquid is more, gas is less, it is called foam. And its example is froth, F-R-O-T-H, froth, whipped cream and soap leather. Whipped cream and froth is the example of foam. Okay, this you have to always remember, because in every examination all eight system of colloids is asked. Okay, and this I have told about classification. Okay, general classification based on physical state. Okay, now I am telling further. Many familiar, you can say, commercial products and natural objects are colloids. Okay, many familiar commercial products and natural objects are colloids. For example, already I have given many examples. Whipped cream is a foam, which is a gas dispersed in a liquid. And new example I am telling you, firefighting foam used at emergency airplane landings, correct? There it is used. Firefighting foams used at emergency airplane landing are also colloids system. Most biological fluids are aqueous salts, means solid dispersed in water. Dispersed in water. Then most biological fluids are aqueous salts. Within a typical cell, in any cell in biology I am talking about, in botany and these things, biology. Okay. Within a typical cell, proteins and nucleic acids are colloidal sized particles dispersed in an aqueous solution of ions and small molecules, correct? Here protein and nucleic acids are colloidal sized particles, both are colloidal sized particles dispersed in aqueous solution of ions and small molecules. Now further I am telling you, out of the various type of colloids, okay, the most common are salts, SOLS. Salts means solid in liquid. Salts means solid in liquids. Okay, already I discussed. And gel means liquids in solids. And emulsions means liquids in liquids. Emulsion questions are, all questions are asked. Then emulsion is more important. Emulsion is liquids in liquids. However, in these things, salts and emulsion, we will discuss here mainly salts and emulsion. Further, it may be mentioned that if the dispersion medium is water, important things, very important things I am telling you now. If the dispersion medium is water, the sol is called aquasol. Aquasol or hydrosol. Hydro means water. Then if the dispersion medium is water, the sol is called aqueous or aquasol or hydrosol. And if the dispersion medium is alcohol, it is called alkosol, ALCO, alkosol, etc. Okay, I have discussed about that. Now, this I have discussed, that is the on physical state, types of colloidal system on physical state I have discussed. Now I am going to discuss classification based on nature of interaction between dispersed phase and dispersion medium. Okay, physical state I told you. Now I am going to second classification, that is the classification based on nature of interaction between dispersed phase and dispersion medium. This is actually very important. All are actually important only. Then now I am telling about this classification based on nature of interaction between dispersed phase and dispersion medium. Depending upon the nature of interaction between the dispersed phase and the dispersion medium, colloidal salts are divided into two categories, namely lyophilic. Lyophilic means solvent attracting, solvent liking, solvent loving, or you can tell lyophilic means solvent attracting, solvent liking, and solvent loving. And second is lyophobic. Phobic means already you know, hater. Then lyophobic means solvent repelling, solvent repelling. If water is dispersion medium, if water is the dispersion medium, the term used are hydrophilic and hydrophobic. If you are considering water is the dispersion medium, then these both terms, means lyophilic and lyophobic, are termed as hydrophilic and hydrophobic. Now you know more about the hydrophilic colloids, lyophilic colloids or hydrophilic colloids. Lyophilic in general. Then what is the lyophilic colloids? The main things you understood. The word lyophilic means liquid loving colloidal salts. Okay, the word lyophilic means liquid loving colloidal salts directly formed by mixing substances like gum, gelatin, starch, rubber, etc. with suitable liquids. That is called dispersion medium. Example are called, these are called actually lyophilic salts. Okay. Here again you listen, the word lyophilic means liquid loving colloidal salts directly formed by mixing substances like gum, gelatin, starch, rubber, etc. with a suitable liquid. Then suitable liquid is called dispersion mediums, are called lyophilic salts. An important characteristics of this salt is that if the dispersion medium is separated from the dispersed phase by evaporation, the salt can be reconstituted by simply mixing with dispersion medium. Means suppose if it was in water, mixed with water, water evaporated, then again you can mix it with water, then you will get this lyophilic colloids you will get just after mixing with water. That's why these salts are also called reversible salts. Okay, if dispersion medium evaporated, then again you if you will mix it dispersion medium, you will get lyophilic salts. That's why it is called reversible salts. Furthermore, these salts are quite stable and cannot be easily coagulated. Okay, this lyophilic colloids I am talking about, that these salts are stable, quite stable, and cannot be easily coagulated, means precipitated. Okay. Now second, lyophilic colloids. Lyophobic I discussed. Now lyophobic colloids. The word lyophobic means liquid hating. Substances like metals, their sulfides, etc., when simply mixed with the dispersion medium, do not form colloidal salt. Simply if you will mix metal and its sulfide, that is called metal sulfide, when simply mixed with the dispersion medium, do not form the colloidal salt. Okay. Their colloidal salts can be prepared only by a special method. Such salts are called lyophobic salts. These salts are readily precipitated, means coagulated. Coagulation means precipitation. Such salts are such salts are called these salts are called lyophobic hater. These salts are readily precipitated or coagulated on the addition of a small amount of electrolytes. Any electrolytes, if you will add addition on the addition of a small amounts of electrolyte, if you will add in the lyophobic colloids, then it will be coagulated. Okay, readily coagulated or precipitated. Or by heating also it will be, if you heat the colloidal solution, then it will be coagulated, or by shaking, and hence are not stable. Means lyophobic are weak, very weak. Okay, simply by heating it will be coagulated. On addition of other small quantity of electrolytes, it will be coagulated, means precipitated, and shaking also it will be precipitated. That's why it is not stable. Once precipitated, they do not give back the colloidal salt. This is the limitation, negative part. Not like that here I told you lyophilic, only by mixing you were getting this colloidals, but here it is not like that. That's why it is called irreversible salts. Means lyophilic colloids were reversible salts, but this is means lyophobic colloids are irreversible. Okay, lyophobic salts need stabilizing agents, okay, as a preservation. If you want for more days to keep it, then some preservation is required. Now I have told you about the second type. Now come to the third type. Okay, third type classification. The first classification I told on the basis of physical state, 8 types system. Second I told this lipophobic and lyophilic colloids. That is the classification based on nature of interaction between dispersed phase and dispersion medium. Now third I am going to tell you classification based on types of particles. Types of particles of the dispersed phase. Okay. Classification, third classification is based on type of particles of the dispersed phase. What type of this material or substance you are mixing, that is the dispersed phase. Then here three terms will come: multimolecular, macromolecular and associated colloids. Three term will use here. Three terms comes under this classification. Okay, then depending on the type of the particles of dispersed phase, colloids are classified as multimolecular, macromolecular and associated colloids. Then first I will discuss multimolecular colloids. Multi, meaning of multi, okay, many. Multimolecular colloids. On dissolution, a large number of atoms or smaller molecules of a substance aggregate together to form a species having size in the colloidal range. Colloidal range means the diameter will be below 1 nanometer. Okay. Again you can see here multimolecular colloids. What is that? On dissolution, a large number of atoms or you can say a smaller molecules of a substance aggregate together to form a species having size in the colloidal range, that is the diameter less than 1 nanometer. That is called multimolecular colloids. Its diameter, particle size will be below 1 nanometer. Okay. After collecting means after aggregation of many, you can say large number of atoms, they will come together and they will form multimolecular colloids, and its diameter will be less than 1 nanometer. The species thus formed are called this aggregate species. Aggregate species means aggregate together, all substance aggregate together. That species I am talking about. Thus formed are called multimolecular colloids. For example, a gold sol, Gold, gold sol may contain particles of various sizes having many atoms. Okay, gold atoms. A gold sol may contain particles of various size, but all sizes will be below 1 nanometer. There examples I told you: gold sol may contain particles of various sizes having many atoms. Second example is sulfur sol. Just like a gold salt, sulfur sol is there. Sulfur sol consists of particles containing thousands or more acid sulfur. Sulfur molecules is S8. S atoms are, when eight sulfur atoms are will meet together, or you can tell that in one molecule of sulfur, 8 sulfur atoms will be there. 8 sulfur atom forms one molecule of sulfur. One molecule of sulfur means 08, 8 atoms of sulfur. It is called S8. Okay, sulfur molecule is called S8 molecule, S8 sulfur. Okay, then sulfur sol consists of particles containing a thousands or more of S8 sulfur molecules. Correct? Sulfur molecules may be can say 1,000 or more. Then it is called this thing sulfur sol. Question is asked about the gold salt and sulfur salt. Now second I am talking about, that is the macromolecular colloids, MAC. Macro means you know that it is a big. MIC macro means small. Okay, MIC is less than smaller than MAC macro. Okay, then macro I am talking about macromolecular colloids. What is this? The macromolecules in suitable solvent form solution in which the size of macromolecules may be in the colloidal range. Okay, size of the macromolecules must be in the colloidal range. Such systems are called macrocolloids. Its size must not be greater than colloidal range, between 1 to 1000 nm. It should be only this range. Okay, this range is called actually colloidal range, 1 to 1000 nanometer. Then if a macromolecular size in this range, then such systems are called macromolecular colloids. These colloids are quite stable and resemble true solution. It will resemble true solution. It will match with that in many respects. Examples of naturally occurring macromolecules are, I am talking about examples which are occurring in a nature. Okay, occurring natural occurring macromolecules are starch. Starch is the example of macromolecules colloid. Macromolecular colloids example is starch, cellulose, protein and enzymes. These are examples. Question is asked. Remember it. Starch, cellulose, proteins and enzymes. These are the example of macromolecular colloids. Correct? And those of man-made means synthetic. What is the example of macromolecules which is made by man means synthetic. Man-made macromolecules are polythene, nylon, polystyrene, synthetic rubber. If we will tell that what is this, these are the polythene, nylon, polystyrene, synthetic rubber, these are polyester, you will tell polymers. But here these are dissolved in suitable liquids. Okay, that's why, and their size is coming under that range, colloidal range. Okay, size in the colloidal range. That's why these are called you can say molecular colloids. But it is man-made, that is called synthetic macromolecules. Okay, synthetic macromolecules, their size in that range only. Then these are the examples of macromolecular colloids. These are exactly dispersed phase. It will be soluble in some suitable solvent. Okay, generally it will be in the water or organic solvent. Now third type, that is the associated colloids. here this is very easy to understand and it is interesting also. Associated colloids, it is also called micelle. Associated colloids are also called micelles. There are some substances which at low concentration behave as normal strong electrolytes, but at higher concentration exhibit colloidal behavior due to the formation of aggregates. Correct? It means it will come under both. Okay. First to understand that association colloid is also called micelles. Very important term. Okay. There are some substances which at low concentration behave as a normal strong electrolytes, but at higher concentration exhibit colloidal behavior due to the formation of aggregates. The aggregated particles thus forms are called micelle. Aggregated particles formed are called micelles. These are also known as associated colloids. Okay, micelles or associated colloids, both are same. Another name is associated colloids. The formation of micelles takes place only above a particular temperature, and this temperature is called Kraft temperature. Kraft, Kraft temperature means TK. Question is asked, what is the Kraft temperature? Then I told you that this temperature, a particular temperature, that is the formation of micelles, takes place only above a particular temperature, above a particular, not below, above a particular temperature called Kraft temperature, that is the TK, and above a particular concentration, not below, above a particular concentration, that is called critical micelle concentration. Critical micelle concentration, in shortcut CMC. C, capital C, capital M, capital C, CMC, critical micelle concentration. Both terms are important for examination. On dilution, these colloids revert back. This is again important things. If you dilute the solution, because it is based on limitation, if you cross this limit either in temperature or in concentration, then what will happen? They will revert back. Okay, on dilution, these colloids revert back to individual ions. Surface active agents such as soaps and synthetic detergents. Now, again, the very important things I am telling you. Surface active agents such as soap and synthetic detergent. Surface acting agent, because this you are using for the cleaning purpose, soap, that cloth cleaning, and these are the agents which is working on the surface of cloth. That's why it is called surface active agents such as soap and synthetic detergents belong to this class. To this class means associated colloids or micelles. Both are called coming under the micelles, soap and detergent. Okay, these colloids have both lyophobic and lyophilic parts. Micelles may contain, you can say, as many as 100 molecules or more. Many molecules it can contain. Here important thing is there, that soap, these colloids means now both are the examples, soap and detergent. Both are the examples of micelles or associated colloids. Then these colloids have both lyophobic and lyophilic parts. Okay, micelles may contain and as many as 100 molecules or more. Okay, then now this I have told about the micelle. Classification is over. Now actually here mechanism of micelle formation, how it forms the micelles means you can tell that cleaning action of soaps, how soap is cleaning the cloth, then it will take more time, means in short time it can't be discussed. It is also called mechanism of micelle formation. Two terms are there, mechanism of micelle formation and second term is cleaning action of soaps. Two terms are there, then it will take more time to explain all the things, hence I will discuss in the next class. Okay, in a hurry because it is very conceptual. It is easy but based on concept. In a hurry you can't understand. Okay, that's why I will discuss in the next class. Thank you.